Okay, geographers, got a new map project, a little exercise for you to do here today. And if you look on the screen, I've got the basics of what we're doing, what you're downloading, where you're putting it. In previous videos, I went into Canvas and showed you how to click on this and download this and how to unzip this thing and all of that. I'm not going to keep repeating that process. Instead, I'll say for this population map of the US that we're going to be making today, you need to find in Canvas this US underscore pop geodatabase. So again, same place, files, data folder, says US underscore pop.gdb.zip. Download that, unzip it. I want you to make a new map project in ArcGIS Pro. Again, much like you did with your first South America map or that data map or anything else you've done to this point, same process. For this map, I simply called it population. So you can see up here at the top. So make a new map called population, unzip that US pop geodatabase. Remember, then copy or drag it into the actual ArcGIS projects population folder. And so that way, in here, in the catalog, if I go, I'm looking at the catalog pane like this, and where it says folders, I open that up, and this would probably be closed when you first look at it. You open that, and you'll see this US underscore pop, as well as that default population geodatabase. It's going to be empty at this point. All right, so go ahead. You can pause this thing, download this, get it set up, but that's what we're doing here. Okay, so go ahead and take care of that. Get to this point, and then when you're ready, let's keep going with this video, and let's make a pretty sweet map. We're gonna do some new stuff today. It's gonna be cool. All right, now that you're ready, in the catalog pane, go ahead and open up our US underscore pop geodatabase, and there's just one feature class in here, the states feature class. I'm going to left click, hold that left click, drag it in, and release it. And what you see, the United States of America, our 50 states right here. And so the first move, well, a couple of first moves. I guess my main first move, I'm going to save because I just did something and we want to save at an obsessive level. So I'm going to do that. But then my next move, because I'm an ArcGIS pro, not some ArcGIS amateur, I'm going to right click and remove this default topographic map and hillshade because I want to make my map. I don't want this preloaded rookie garbage in there. So I've got my United States. Now looking at this, in fact, let's save. Let's be obsessive. Um, Looking at this map, you should feel horrible, right? Looking at it. If you're a good red-blooded American, you look at this and you go, outrageous. You don't even have to be an American national. You should still, I don't care where you're from, Argentina or whatever. You should look at this and you're like, I feel sorry for those Americans. Just looking at this map, it looks like garbage. Okay, it looks like garbage. And I'm not saying because of this awful pastel green that it came in as. I mean, that's a horrible green. I don't like that at all. But that's not what I'm talking about. And we're gonna mess with the actual color of the map later, so I'm not worried about that. But what I don't like is how droopy the U.S. is. You've got squished Alaska here. Hawaii looks okay, but everything here in what we call the contiguous United States, right? The 48 states that are actually touching and right next to each other. It's droopy. It's sagging. It is not powerful at all. And what this is, the reason why it looks so bad, it has to do with what we call projections as well as coordinate systems. And this gets a little weird with how Esri uses the terminology, how it's actually used. So I'll bring you up to speed with this. And it also might seem kind of daunting as we begin to mess with some of these very geographic and theoretical concepts in here, but don't worry about it. It's easy, and we'll make it easy as we go through. So our first move with this map is to simply make it look good, right? To address this whole coordinate system slash projection issue. Okay, so here's what we're going to do. Follow along. First thing, go up to where it says map. Okay, and so this is our map frame or view or whatever. This is the one it just kind of defaults to, right? And it's just called this generic map. Now we're actually going to be working with 3 of these for this project. So we're going to add some of these, like where it says new map right here. We're going to keep doing that down the road. So our move will be to right click, come down here to properties at the bottom. And don't worry about coordinate system. If this pops up, go up to general. If it starts in general, you're cool. Just wherever it is in here, it's the last thing you played around with is where I think it stays. But go to general up at the top, and it says name, and it has this map. I'm just going to call it US. In fact, no, I'm gonna do United States just to spell it out. Doesn't really matter. I don't like the way US looked. Yeah, and if I hit apply, it changes that name over here. It changes it up here. And so when we have 3 separate map frames, or it used to be a data frame, there's the term. I don't. They changed terms with new versions of software. I don't know. But we're gonna have 3 of these things, so we want to have them labeled so we know which one we're dealing with. We're gonna take that initial step to kind of sort these things out. Okay, so all right, we got that. Then you need to come down here to coordinate systems. And I'm going to explain how this all works. So, with the term coordinate system, what that really is referring to is latitude and longitude, or universal transverse Mercator, or state plane, or a number of these different grid systems we have to figure out where things are located, right? It's based on an X and Y axis. It's just like, plotting points in an algebra class or whatever. It's the same way that latitude and longitude works. We're just plotting points on the map. So that's what coordinate system is truly referring to. Okay. But the way Esri uses this is they kind of conflate coordinate system and projection, which is something different. They put it all together. So it's kind of stored in one place. And it can be a little confusing at first when you're trying to figure out how to work with this stuff, but honestly, it's cool. We shall overcome. But a map projection, is how we take the fact that the Earth is round, right? It's a naturally round surface, and we're trying to make it flat, right? We're unrolling it or peeling the globe, or however you want to look at that. We're trying to take this round surface and make it a flat thing, whether it's on a piece of paper or on your screen that you're looking at, right? So if I look at, let me move this over a little bit, the United States, it doesn't have any curvature like I'm looking at the globe. It's flat. Now, the thing is, to go from a round surface to a flat surface, that's impossible to do without introducing some distortion, which, you can read distortion as error. There's some problems in here. We're stretching things, tearing things, altering that surface to try to make it look nice and flat. Okay, that's what a projection is. How do we go from round to flat? Every single projection that exists has some good things about it and some bad things about it. It's a case where they all have error in some capacity, or there are spots on the map where it's really not that great. But then there are other spots where it's good, or it's useful for this task, but maybe not for that task, right? So that's the idea with map projections, is they all are flawed in some way, but they also have some strengths. Okay? So there's no one good map projection. no one good way to take round and make it flat. We have a lot of options. All right. Now, that's really what we're looking at here. Um, so, with this coordinate system thing, you can kind of think of it more as how am I going to project this round surface onto a flat computer screen, onto this display? Now, what Esri does is it has two different kind of main folders. This geographic coordinate system, and if you hit the drop down here, it's got a bunch of other subfolders in there, and then it's got projected coordinate system, and again subfolders in there. So there's a lot of options that we have. Number one, when we're just kind of trying to change our display, like we're doing now, okay? In the map properties thing, when you right click and hit map or properties rather in here, and we change the name and all that stuff. When we're messing with it here, we're simply changing how it's drawn on the screen. We're not altering the data in any way. Okay. And in future endeavors, you'll get into actually changing the data, and we'll get into why that is. And this really gets important when you start to do true analysis of the data. When you're comparing multiple layers, you want to ensure that everything's projected into the same coordinate system, and you're using specific ones. And there are rules and things that you get into as you continue to work with this. But with this, we're simply making it draw our map, in a better way, in a more attractive, aesthetic kind of way, right? We're just going for a look at this point. So that's what we're doing. And if that's the case, I never want to use these geographic coordinate systems. That's what we're in right now. Okay. And it's saying, in terms of, this layers thing, if that's not open, you just hit this little triangle deal. It's looking at the different map layers that we have over here. Now, I only have one, the States one, but it's in this WGS 1984 coordinate system. It stands for the World Geodetic System of 1984, but it's one of these geographic things. It's a very simple, basic deal. Esri likes to use this for how they share data. For some reason, it's good. I don't know. But this is what it looks like. Okay, this is what we're seeing. This dumpy, drooping, sad. I mean, this makes bald eagles cry right here to see the United States like this. So we don't want this. We never want to pick this geographic coordinate system stuff. So that means if you're trying to make this look pretty, open up your projected coordinate system folder. And like I said, we got a lot of stuff in here. Can I make this bigger? Yeah, so we can see everything. So we got a lot of options, and you can open these up, and there'll be even more options in here. And a lot of this stuff gets a little scary because you just see weird acronyms and numbers and things like that, and things that seem similar, but there's clearly a difference, and like, what's going on? This NAD acronym stands for North American Datum. We have one for 1927, one for 1983. So these are just some different. They're what we call. I'm trying to think of how to explain this without getting too nerdy in just this intro video, but they're what we call datums. Okay, which is kind of datum is actually a singular word. The plural is data. But datum, in this sense, refers to an origin point for modeling and mapping out the Earth. Okay, that's the idea behind it. And you don't need to know all the nuance of these things to be able to be a good GIS analyst or specialist or professional or whatever. But it's good to know the basics, right? And the idea being that NAD 27 is different from NAD 83. Obviously, it's a different thing, but it's that origin point is actually different. This becomes very important when you start working with GPS and trying to actually get coordinates from your GPS receiver and plot them on a map and to figure out like where you are or to record something from the field or whatever. This becomes very important in that case. We're not to that yet, and that's a topic for like future classes or whatever, but that's the idea with this. These are just simply different origin points for how we map out and model the planet with these map projections. Now, state plane is something we're not going to worry about. That's more important if you're doing kind of public works engineering type work in the state of like California, we use state plane for a lot of this stuff. Yeah, and you'll know. I'll point out some of these things as we go. Good ones to use. UTM, Universal Transverse Mercator, is a good one. We'll get into that at some point. But with this, because we're simply trying to make the US look good, let's get into continental. All right, open that one up. And we've got some options, but I mean, it should be pretty obvious. Clearly, we don't want Asia or Europe or whatever if we're dealing with the US and North America. So open up North America. And in here, we have a lot of options. And the nice thing about these is that they kind of let you know when you should be using it, right? Like this Canada, Albers Equal Area Conic. If I'm making a map of Canada, yeah, that might be a good choice, right? I'm not trying to show Canada here. So like it might work, but why would I choose that when there are other things, right? Like contiguous USA. We've got multiple options in here. So you can scroll through and look at these. But we're going to find something that works for the US because that's what we're mapping. Albers refers to a person who developed this projection. Equal area refers to one of the properties that it maintains. So it preserves area, or what we call equivalence, in that you're not going to have weird stretching or distortion. The scale for California is going to be the same scale that exists over in Maine or Florida or wherever on the map. So it preserves size. That's what it is. And conic refers to, it's an old projection thing, the shape that's being made flat. Don't have to worry about that for this. So I'm going to look through, and I've got, NAD 27 contiguous USA Albers, NAD 83 parentheses 2011. I don't know if they updated some stuff. I don't know what the 2011 is, but whatever. But contiguous USA Albers. Then I've just got this 1983 contiguous USA Albers. There's a lot of options that we got here. So I'm going to look through, and because I already know what we're going to do, I'm going to go ahead for some consistency. I want you to come down here. Okay, North America, Albers, equal area conic. That's the one I want you to use. All right, so select that one. It gives you this little star and a plus sign, and you can add it to favorites. That's nice if there's certain coordinate systems that you're constantly using, so you don't have to come back in here and find this stuff. If you knew specifically, too, this is the one you wanted, you can type that into the search bar here. Although, honestly, I a lot of these I don't have memorized, but I know where I can look for them in there. But it's up to you. Different ways to get at this stuff. But I want you to select that and hit apply. Oh, just I want to recite the Pledge of Allegiance right now. Look at that. We've tightened up. We're not this stretched out, droopy looking thing, this sad, failing nation. This is a nation of hope. Right here. I like this. And so I'll just hit OK, right? Once it looks like this. Now Hawaii looks funny. Alaska is okay. But here's the thing. I'm not really worried about this at this point because what I'm going to be doing here, I'm going to hit my shift key. I want to zoom in to just the contiguous United States here. So I'm hitting shift and I'm clicking up here above Washington, right? Left clicking and holding, dragging, making this little rectangle here, releasing. So I'm zooming in, okay? Just to get rid of Alaska and Hawaii for now. And if it's not obvious, like I said, we're going to have 3 of these things. Yeah, we're going to make one just for Hawaii, just for Alaska. And our final map, we're going to be mapping out population. We'll have 2 little inset boxes down in the corners. So we'll have a separate map for Hawaii. So everything just kind of fits on a page, looks nice, looks professional. But for this is what I want to see. Okay. So, and maybe it doesn't look that different to you, but for me, as someone who deals with maps and looks at this stuff, I mean, this is a huge thing right here. Not only do I think it looks better, but if I get a map from someone and it's that droopy stuff, in fact, can I go back and yeah, let's do that. If I get a map of the US and it looks like that, I'm going to question how good that map is, right? And how qualified the person who made the map is, because they don't know about projections and coordinate systems and all that, or they're too lazy to make that change. And it just doesn't look very professional, right? So it could be a great map, a great analysis, and all this work that went into it. But if it looks like that, I'm not trusting it. I'm not going along with it. All right. But if I have something that looks like this right here, I go, okay, they know what they're doing. They know some of these little things. I'm going to be more trusting, going to kind of go along with what's happening there. All right. So, first step with all of that, I know I've said like first step for like 8 things we've done, but go with me. But the first real, move forward on this little project, this exercise that we're doing, is to make the US look sexy. And I think we accomplished that. We're going to fix the colors and all that in the next video. I'm going to stop this one here and start a new video. But yeah, there you go. There's our first step. I'll just go with it. All right. Okay. Save what you got. Hold tight. I'm going to make this next video right now. You don't have to hold tight. It's going to be instant when you're looking at this. Look. All right. Save it. Go on to the next video. Yeah.